Hello everyone, I hope you all are fine amidst this COVID crisis. Today we will learn about non-inverting amplifier using op-amp. I hope you all have revised the pin configuration of op-amp and the basic characteristics of op-amp. Those are always required when you're dealing with circuits related to op-amp. Okay, so the circuit diagram of a non-inverting amplifier with inverting terminal should be grounded to okay, I'm drawing, see how it works. Well, this is pin number 2, that is the inverting terminal. This is pin number 3, the non-inverting terminal. And we will be applying voltage to the non-inverting terminal as the name suggests. So keep your inverting terminal grounded. So we are not going to apply any voltage in this section. So this is R1 and this is our feedback path. So this is, say, RF. You can take this as R2, but since I'm mentioning the feedback path, so I'm writing as RF. This is the output section, and very important over here, let this point be as G for our convenience, and we will be applying voltage at this non-inverting section. As the name suggests, if you apply a signal, say we are applying a signal in this format, okay, over here in this section, then the output part will be non-inverting. That means it wouldn't be inverted. Okay, so we'll just get an amplified version of the same signal. I hope you're understanding what I'm trying to say. Okay, so the signal wouldn't be inverted as we have seen in the case of inverting amplifier. Okay, I hope it's clear. So I have freshly drawn this on the next page so that our calculation can be done easily. Over here, from this figure you can see, let us consider the voltage at this point number G of the inverting terminal, as suppose I'm taking that to be V. So the total input voltage will be what? VI minus V. Okay, because over here the potential is V, so the input section will give you a total voltage of VI minus V. Since this is an ideal op-amp, so the open loop gain will be infinite. So let me consider the open loop gain to be, say, A. You can name them anything, I'm taking as A. That would be output by input. It should be infinite as per the characteristics. So this actually fetches you that VI is equal to V from this point. Okay, so since the input impedance of the op-amp is infinite, so no current will be passing through the op-amp. Now if you apply Kirchhoff's law at point G, then what will you get? If you apply Kirchhoff's law at this point, at point G, we'll get I hope my screen is visible. Let me take a new page. Okay, so applying Kirchhoff's law at this terminal at point G, we can write V naught minus VI, okay, by RF is equal to VI minus 0 by R1. Why? Because this is grounded, this part, so VI minus 0 would be grounded. Fine. Therefore, or we can write V naught minus VI by VI is equal to RF that is the feedback resistance by R1. I'm just changing the sides of this equation, and you get V naught by Vi is equal to 1 plus Rf by R1. Okay, so this is actually the gain, that is V naught by Vi. This is your gain. This gain can be represented in the format, say I can write as AF is equal to V naught by Vi is equal to 1 plus Rf by R1. So the gain with feedback is given in this format for a non-inverting amplifier. I hope this section is clear to you all. If you have any kind of queries, drop in your questions in the chat box, or you can also write to me. Okay, so stay safe all until our next class. Thank you.